The physics behind billiards involves collision between billiard balls. When the two billiard balls hit each other, it creates an elastic collision. An elastic collision is one in which the kinetic energy of the system is conserved before and after impact. In this situation, when there is an encounter between two bodies in which the total kinetic energy of the two bodies remains the same. When the two billiard balls collide, the momentum is always conserved. In this case, there's a thing called a sweet spot where you can strike the cue stick so that no friction force develops between the ball and the billiard table. Knowing the location of the sweet spot can give you an idea where to hit the ball so that it develops a backspin or a forward spin, which can be useful for making a shot. Whenever you strike the ball, it travels from different parts of the pool from what you have expected. In physics, there are three Newton's law of motion. In this particular predicament, we can assess the sweet spot of the ball by using Newton's second law of motion, which states that the acceleration of an object is dependent upon two variables. Number one, the net force acting upon the object, and the mass of the object. We need to further analyze the height of the ball, and we are pointing the end of our cue stick. In this process, we can lessen the amount of the rotation of the ball due to friction and land a clean shot to the hole. When we are trying to hit a straight shot, this is a perfect example of Newton's third law of motion, where every action has an equal and opposite reaction, and in this case, the linear momentum enters the scene. In billiards, it is also include the frictional force. It refers to the force generated by two surfaces that contacts and slide against each other. The angle and position of the object affects the amount of frictional force, and that is the physics of billiards.